All right, your final, guys, your final test. I just made it. I think it's 15 questions. It'll be a little longer than your quiz was, but it's going to cover solving linear systems of equations like this. It's going to cover solving nonlinear, which means they have the x squared, y squared, or both. It's going to cover partial fraction decomposition. And then it's also going to go over the back substitution, and when you have the three equations with the three variables, rearranging it so it says back substitution and then working backwards. So those are the longer types of problems. What I have here at the top, it says refer to the College Algebra Trig Senior Final Test Review. The review is on Canvas for that. The solutions are on Canvas for that. And there's a YouTube video that I did working every single one of those problems out. So in addition to this, you also have that review that we did for your quiz number 3. That also is posted on Canvas, and you have the review video, and you'll have this one. So there's a lot of stuff that you guys can look at to say, hey, I need to practice this, I need to do this again. So let's look at this first problem, all right? I didn't number them, I'm not sure why I didn't, but it says to solve, all right? It's not going to tell you solve using elimination, solve using substitution, solve using whatever. It's going to just say solve. You guys can do it how you would like, all right? I do need to see work. I don't need to see the checks, but I do need to see the work that you guys were working through it, that you did what you were supposed to, that sort of thing. So in this case, I look at this equation, and I can solve for x or I can solve for y. It doesn't matter. What do you guys want to solve for? X's or y's? Y? Okay, so all I'm going to do is I'm just going to multiply the whole top equation by -1. All right, so my y's will cancel out. So this becomes negative 2x. This becomes a negative 4y. And this becomes a positive 4. You guys with me on that? So when I do that, combine the two equations, negative 2x and negative 4x is negative 6x. My y's will cancel. And then a positive 4 and a negative 28 gives me negative 24. Divide both sides by negative 6. And x equals positive 4, yes? Okay, so x equals positive 4. Now that I know that x equals positive 4, how do I find what y equals? Plug it in. To either equation, it doesn't matter. So I'm just going to go to the top one. 2 times 4 plus 4y equals negative 4. So I have 8 plus 4y equals negative 4. Subtract 8 from both sides. 4y equals negative 12. Divide both sides by 4. And y equals what? Negative 3. So my ordered pair would be 4, negative 3. And how do I know for sure that I'm right? Plug it back in. Just make sure that the solution works. All right? Questions on that one? All right, let's go to the second one. Now, you can solve this equation just leaving it exactly like it is. Or you can get rid of all your decimals. So if I wanted to get rid of decimals, I would multiply this whole top equation by 10, because it would move each decimal point over 1. I would multiply the bottom by what number? 100, right? Because we want it to move over 2 places. So when we do this, we have 1x plus 4y equals 7, and then 5x plus 20y equals 6. Everybody with me? Now, cancel out whatever you want. It doesn't matter if you want to cancel out the y's or the x's. I'm going to say x just because if I multiply the whole top equation by negative 5, right? What we do to one side, we do to the other, so all the way through. So I have negative 5x minus 20y equals negative 35. So 5x and a negative 5x cancels. Positive 20 and a negative 20 cancel. So I'm left with nothing on this side. And then I have 6 and a negative 35 gives me negative 29. Is that a true statement? Does 0 equal negative 29? No, that's not a true statement. So what would your answer for this one be? No solution. Now, no solution is when you have an untrue statement at the end. If your answer ended up like this, what is the answer here if it's 0 equals 0? Infinite, correct. Infinite many. Infinite many solutions. Two different scenarios. This 0 equals negative 29 is an untrue statement. That will never ever be. So that's why it's no solution. 0 equals 0 means everything cancels out. It's the exact same line on top of the same line, so anything on that line will work. Very different scenario. All right, if you have a problem like this, you can work with fractions. We can change it to a decimal. What's another thing that we can do, though, so we don't have to worry about a denominator? What could we multiply this top equation by to get rid of that 5s as my denominator? 5. If I multiply all of this by 5, I'll get rid of that denominator, because when you multiply, it's 5 times 3 is 15. Well, 15 divided by 5 is 3, so this is 3x. 5 times negative 4 is negative 20 divided by 5, just gives me what? Negative 4, y, equals 5 times 2 is 10. Now this is already set up. What can we eliminate? Y's, okay? So 7 plus 3 equals 10x. My 4's cancel out. What's 10 plus 10? 20. Divide both sides by 10. And I get x equals how much? 2. Now how do I figure out what y equals? Just plug it back in. So I'm going to go to this one right here. So 7 times 2 plus 4y equals 10. 7 times 2 is 14 plus 4y equals 10. Minus 14 from both sides. And I get 4y equals negative 4, right? Divide both sides by 4, and y equals negative 1. So my ordered pair is x is 2 and y is negative 1. And how do I know for sure that I'm right? Just plug it back in and check. Question so far? All right, this one's already set up nice and pretty. What is it already set up for us to do? Eliminate the x's, okay? So 2x and negative 2x cancels out. Negative 2 and a negative 3 gives me negative 5y equals negative 2 and 12 is 10. So we're going to divide both sides by negative 5, and y equals negative 2. Go back up to the top one. 2x minus 2 times negative 2 equals negative 2. So 2x, negative 2 and a negative 2 is a positive 4 equals negative 2. We're going to subtract 4 from both sides. So 2x equals negative 6. Divide both sides by 2, and x equals negative 3. So my ordered pair is negative 3, comma 2. So any kind of these solving linear equations is fair game. If it says by graphing, all right, you guys are going to say, do I have to write out a graph? No, you don't have to write out a graph, but there's a graphing problem on here that we're going to look at, and I can show you exactly how you would go about solving if it was talking about graphing. What I need to see for you to get credit for your work. All right, if I look at this one here, this one is a little bit different because this is a nonlinear. Nonlinear meaning you have an x squared or a y squared or something. Easiest thing to do in this case is to just solve for one of the variables, that is to the first power, and then plug it in. So I'm going to solve for x because if I move y over, it becomes positive. So x equals y minus 4. Again, you could have solved for y. You'd have moved x over and then divide everything by negative 1. It doesn't matter. But I'm going to take this value, I'm going to put it right here. So instead of x, excuse me, I have y minus 4 quantity squared minus y equals 2. When I have y minus 4 quantity squared, that means I have y minus 4 times y minus 4 minus my y equals 2. So now we go about simplifying. We're going to FOIL. Y times y is y squared. Y times negative 4 is negative 4y. Negative 4 times y is negative 4y. Negative 4 and a negative 4 is a positive 16. And then I still have minus y. And then what can I do with this 2? Since I know this is a quadratic and we're going to have to factor it, what should I do with that 2? What should I do with that 2 at the end? We're going to move it over. It's positive, so we're going to move it over here. It's going to become negative. So minus 2 equals 0. So now we just combine our like terms. I only have 1y squared. Negative 4y is negative 8. And then another 1 gives me negative 9y. And then 16 minus 2 gives me a positive 14. So now we go to factor. What are the factors of positive 14 that are going to add to give me a negative 9, but multiply to give me a positive 14? What would those two be? Multiplies to give me negative 14, adds to give me negative 9. Yep, negative 7 and negative 2. So when you solve those, you set each parenthesis equal to 0. You get y equals 7, and you get y equals 2. Okay, so now we take one more step. Oh, my Apple Pencil's about to die. Great. We take one more step, and we're going to substitute in. So I'm going to take the easier of the two equations. X minus y equals negative 4. X minus y equals negative 4. X minus y equals negative 4. So I'm going to plug in 7. So x minus 7 equals negative 4. Add 7 to both sides. And my x value is 3. So this ordered pair is 3, 7. And then over here, I'm going to plug in 2. So x minus 2 equals negative 4. Add 2 to both sides. And x equals negative 2, right? So our ordered pairs are 3, 7. And negative 2, positive 2. And to check it, you just plug back in. But what this means is these two equations, when you graph them, they would intersect. They'd cross over at those 2 points. Questions? I'm going to do these last 2 on this first page and then the next 3. And then I'll finish up tomorrow. All right, so if you look at this one, guys, same thing. I have a nonlinear equation and a linear one. So the easiest thing to do is just solve for a variable. Generally, it's the one that's positive and it's to the first power with no coefficients. So I'm going to solve for y. That means I'm going to move this 2x over. So y equals 2x plus 4. I'm going to take that value and plug it in right there where I see a y. So I have x squared plus, instead of y, I have 2x plus 4. And then I know that I'm going to have to move that 3 over, right? So why don't I just do it now? What does that positive 3 become when I move it over? Negative 3 equals 0. So I have x squared plus 2x plus 1 equals 0. So let's factor. What are the factors of 1 that multiply to give me a positive 1 when I multiply, but add to give me a 2? 1 and 1, good. So when you solve these, you guys get x equals negative 1. Do I need to write x equals negative 1 2 times? No, because when I plug in negative 1, I'm going to get out one y value, and then it's just going to be the same point repeated. So we're going to go back up to the original, and our easiest one would be negative 2x plus y equals 4. So negative 2x plus y equals 4. Is it 4 or negative 4? 4. Yeah. So I have negative 2 times negative 1 plus y equals 4. 2 plus y equals 4. Minus 2 from both sides. And y equals how much? 2. So my ordered pair that satisfies these two equations is negative 1, 2. Questions? Comments? Concerns? All right, let's see how much time I can get out of my Apple Pencil here. All right, the next one says solve by graphing. Now, I know some of you are going to say, well, how do I show my work if it says to graph? I don't want to draw a graph. You don't have to. In order to graph a line, it needs to be in y equals mx plus b. So let's do that. This is how you would show me your work. I'm going to take this negative 2x and put it over here. So we're in y equals mx plus b form. Negative 2x, when you move it over, becomes positive. So 2x minus 6 My slope is a positive 2 over 1. My y-intercept is at negative 6, and it's a positive line, so I know it's going to be going this way. So I say, okay, negative 6. I'm going to go down here to negative 6. And I'm going to go up 2 and over 1. Up 2 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 over 1. You guys get the point. All right, it's a positive line, so remember your line should be sloping upwards. So this is what my first equation should look like. Again, if you're showing me your work, you don't necessarily on a multiple choice test have to graph it, but you can show me this to show me you know how to pick which line matches which. So here, I'm going to take this 3x and move it over. So we're in y equals mx plus b. Y equals negative 3x plus 4. So my slope is negative 3 over 1. My y-intercept is at 4. So I go up to 4. And it's going to slope downward since it's a negative line. So I go down 3, 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1. 1, 2, 3 over 1. Now when we graph, the point that they intersect is our solution. Pretend that's the straightest line you've ever seen in your whole life. My solution is right there. What is that point? It's at positive 2, negative 2. On a multiple choice test, very easy. I bet you one of the answer choices is negative 2, positive 2. Just don't make silly mistakes. Take your time. You guys will have time to do things, so just don't make silly mistakes. All right, let's move on to page number 2. Again, I'm going to finish these 3, and then we'll talk about some places that you can find more material to study from. But when we have back substitution to solve a triangular system, guys, look, this makes like a little triangle. That's why it's called the triangular system. Back substitution means you work backwards. So they're telling me what z equals. All right, I have to do a little bit of work to find out what z equals, not negative z. But you're going to answer your question in an ordered triple. So I'm going to divide both sides of this by negative 1 because we want it to be positive z. So z equals 1. You guys agree? So I'm going to put right here z equals 1. Now I'm going to take this value and I'm going to put it right there and figure out what y equals. So 2y plus 8 times 1 equals 8. 2y plus 8 equals 8. Subtract 8 from both sides. 2y equals 0. Divide both sides by 2, and y equals 0. Is that an acceptable answer? Yeah, y could be 0, absolutely. So I'm going to put 0 here. So now that I know what y and z are, I'm going to plug it into the top equation to find out what x is. So 4x minus 3 times y is 0, plus 14 times 1 is our z, equals 3. So 4x, negative 3 times 0, just crosses out. 14 times 1 is 14, equals 3. Subtract 14 from both sides, and you get 4x equals negative 11. Divide both sides by 4, and you get x equals negative 11 over 4. Now when I did this morning with first period, I went back and I'm like, wait, I must have done something wrong. Why isn't it 12? 12 divided by 4 is 3. It's nice and pretty, okay? Sometimes you get a fractional answer. That's all right. But when you go back and check, if you don't want to plug in using fractions, this is a terminating decimal. 11 divided by 4. That's going to give you a negative 2.75. So you can just plug it in using the decimal equivalent if you want. But there's our ordered triple. It's not an ordered pair because you have 3 answers. All right, same thing here. What's the first thing I have to do to z? I need to divide by 2. Good, because I wanted to say just z equals, not 2z. So z equals 1/2. So immediately, why do we have another fraction? It's okay. 1/2 is the same as what? 0.5. Okay, so if you want to use 0.5, go ahead. No worries. I'm just going to leave it as a fraction because fractions don't scare me. And I'm going to take this, I'm going to plug it in right there. So 2y plus 8 times 1/2 equals 8. 2y plus 8 times 1/2 is just 4 equals 8. Subtract 4 from both sides. 2y equals 4. Divide both sides by 2, and y equals what? 2. Good. All right, now we have a y value, we have a z value. Let's plug it into the top and find out what x equals. So 4x minus 3 times 2 plus 16 times 1/2 equals 6. So 4x, 3 times 2, it's just going to give me minus 6. 16 times 1/2, that's 16 divided by 2, gives me 8, equals 6. So 4x, I have a negative 6 and a positive 8. That's going to give me a positive 2. So plus 2 equals 6. Minus 2 from both sides. 4x equals 4. Divide both sides by 4. And x equals how much? 1. So in this case, our ordered triple is 1, 2, and 1/2. Very important, especially when we have our 3 equations and our 3 variables, to go through and check. Because sometimes our answer can look nice and pretty and it seems like we did it right, and then when you go back and check, you're like, whoops, wait, this doesn't work out. All right, let's do the last one. Let's do the last one together. I want my last equation to say z equals. It does not. It says negative z. So let's divide out a negative 1. So z equals negative 3. All right, so I know I have an ordered triple. I need an x, I need a y, and I need a z. I know my z is negative 3. Well, that's not a pretty 3. So now I'm going to say, all right, let's take this and put it right there. So 2y plus 3 times negative 3 equals 7. 2y minus 9 equals 7. What am I going to do to both sides? Add the 9. Great. So 2y equals 16. Divide both sides by 2, and y equals 8. So now that I know what x equals, just kidding, I know what y equals and I know what z equals, I'm going to take those and plug them in to find out what x equals. So I have 4x minus 3 times 8, because that's my y value, plus 16 times negative 3 equals 7. 4x minus 24, 16 and negative 3 is negative 48, equals 7. All right, we have 4x minus 24 and 48 is 72, equals 7. This is another one. This morning when I did it, I was like, wait, something has to be wrong. Right, because when I add 72 to both sides, 4x equals, what would it make sense that 4x equaled here? So it'd be pretty. 80, huh? But it's 79. So I went back, I'm like, uh-oh, where did I make a mistake? I didn't. This is just a nifty little problem that has another fractional answer, but that's okay. So I'm going to divide both sides by 4, and I get x equals 79 over 4. All right, if you divide that out in your calculator, 79 divided by 4, it gives you 19.75. It's a terminating decimal, so you could definitely use that to go back in and check your work, 79 over 4. But don't freak out because you get a funny looking fraction or something like that. I don't want you guys to think, uh-oh, something's wrong. Don't immediately doubt yourself. That's definitely not what we want to happen. All right? Okay, so that's the first part of our review. Tomorrow, I'm going to finish. We're going to do the solving the 3 equations with the 3 variables. Those take a little bit of time. And then we have some partial fraction decomposition stuff to go through. So by the time Tuesday afternoon has come, you guys will have all of your problems worked out for your review. The video's uploaded. So over the long Memorial Day weekend, you really need to take that time to practice some of these problems. So you can come into the review day and say, okay, I need another one of these, or how do I do this, something like that. That make sense?